show that problem statement again. Okay. Is it visible? My screen?
Yes, ma'am.
Okay. So we have solved this problem statement yesterday during the lecture. And for the same problem, we continued with the second problem, that is considering two bars are bent up. Okay. And we decided three different zones. So I will write down now whatever the calculations you have done yesterday. You just quickly tell me the data. Okay. So for zone 1, I think we have considered the zone 1 for 0.8 meter length. Am I right?
Yes, ma'am.
So anybody from you who have completed the design for second problem, I will write down the details only. That is for zone 1. What are the details for shear reinforcement? So what is the diameter of the reinforcement you have selected, whether it is 2-leg, 4-leg, expected is 2-legged only, and what is the spacing? Give me that data.
Ma'am, 2-legged and spacing is 290 mm.
2-legged, and what is the diameter of the bar?
10 mm.
10 mm diameter. Okay, and
290 mm spacing.
290 mm spacing, center to center. 290. Okay. Zone 2.
Ma'am, I'm getting a different value.
Wait. Let him finish first. Then we'll discuss one by one. Okay, Ritik.
That will be here only.
Sorry.
Well, I have done only zone 1.
You are done only for zone 1.
Ma'am,
Huh.
for zone 1, it is 185 mm.
With same this data, 10 mm bar diameter and 2-legged.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay. So this is wrong. Huh? 185 mm.
185.
Okay.
Yes, ma'am.
Second zone.
Second one is 160. Means same.
Okay. $160 center to center. 160. Am I right?
Yes, ma'am.
So for zone 1, the spacing is higher, 185. Zone 2, the spacing is reduced. How it is possible? Zone 1 means it is the zone near the support where your shear force will be maximum. And as you move towards the center of the beam, your shear force will go on reducing continuously. So in the extreme end zone, that is near the support, your spacing is 185 mm. So this spacing must increase zone 2 spacing.
Ma'am,
is
but in
happening
zone
now?
1, there is bent up bars, so some shear force will be resisted by the bent up bars.
Okay. So that's why the spacing is coming larger in zone 1.
Yes,
Yes,
ma'am.
ma'am. Yes, ma'am.
Everybody is getting the same answer.
Yes, ma'am.
Let me check. Okay. Zone 1, zone 2. No. Okay, tell me what is the VUSB value in zone 2? It is 0, right?
Yes, ma'am.
Yes, ma'am.
So what will be the total shear force for which you are designing the shear reinforcement? VUSB value. I want for both zone 1 as well as zone 2.
Ma'am, zone 1, it is 179.73.
Okay. Okay. So
And
for
for zone
10
2,
mm, Wait,
70.
10 mm two leg stirrups, you are getting the spacing of 185 mm.
Yes, ma'am.
Huh. And for zone 2, what is VUSV value you are getting?
210.8.
210 point.
210.
Okay.
48.
Okay. And 10 mm two leg stirrups?
160 mm center to center spacing.
Okay. All right. Fine. And for zone 3?
300 mm.
300 mm.
Correct. So I just wanted to check whether you are only following these steps or you are actually considering the concepts also behind the changes we are getting in the zone. I just wanted to check that, and your answers are correct. No problem. Okay, so only 3-4 students have solved the homework. Others, I don't know what is happening. But if you don't keep touch in design based subjects every day, see, it is like a mathematics. You have studied the math subjects in school days, right? So every day if you do some practice, it will keep it will you will remember all the concepts regularly, and it becomes easy to prepare for your final exams. So whenever I give the homework, I expect everybody should complete it. At least you should understand what is the concept going on and where we are going wrong, where our calculations are going wrong, and definitely how to use the code, that also you will get a practice in. Okay, so this is about the second problem. Then let us move to the next problem. Just write down this problem statement. Now, this is the another type of a question which can be asked based on design of shear reinforcement. I will just read the problem statement. Hope everybody is noting down this. RC beam has a support section with width of 250 mm and effective depth of 500 mm. The support section is reinforced with 3 bars of 20 mm diameter on tension side. 8 mm two leg stirrups at a spacing of 200 mm center to center is provided. Calculate the shear strength of the support section. M20 grade concrete and Fe415 grade steel are used. So if you compare the given data in the earlier problem and in this problem, in the earlier problem, the dimensions of the beam were given. The main steel area or the area of the steel present in the tension zone was provided, and we were supposed to design the shear reinforcement. Here, along with the dimensions and area of the steel present in tension zone, the details of shear reinforcement are also given, and we are expected to calculate the shear strength of support section. It means in earlier problem statement, VU was given and we are expected to calculate the shear reinforcement details. Here the shear reinforcement details are given. We are expected to calculate the VU. External load acting on a beam is not given. It means what is the shear carrying capacity of a section we have to calculate. Okay, so we are expected to calculate the VU value, total shear force, that the given section can carry safely without failure. Is it clear, everybody, what we have to exactly calculate? Is it clear? Guys?
Yes, ma'am.
Okay. So, have you written the problem statement or should I wait for 1 minute?
Wait for 1 minute.
Okay.
Done, ma'am.
Okay. So let us solve the problem now. Quickly, let us write down the given data first. Okay. So let me write down the given data. I think the width is given. Width of the beam
250.
250 mm.
250 mm. Then effective,
Small d 500 mm.
correct. Okay. Then details of reinforcement are given. So directly we will calculate AST now. So pi by 4, what is the diameter of the bar?
20 mm.
20 mm square into number of bars.
3.
So tell me AST now.
942.47.
0.47. Okay. Now the details of the stirrups are also given. So I will just write down the stirrups. What is the diameter? 8 mm, right? 8 mm diameter, two-legged. What is the spacing?
200 mm.
200 mm center to center.
Okay, center to center. Okay. Now, what is expected to calculate? Capacity of the section. Am I right? That is the calculate the shear strength of the support section. It means we have to calculate the capacity of the section to resist the shear. So now the capacity of the section, as we have discussed in yesterday's problem or during while discussing the design steps for shear reinforcement, the entire shear force acting on a beam is carried out by different components. The components, instead of components, I should say different materials. Okay, the some component of the shear total shear force will be resisted by the concrete, and some component of the shear force will be resisted by the reinforcement. Now the reinforcement, again we have to consider two types of reinforcement. One is the reinforcement which is provided in the tension zone, and second is the reinforcement which is specifically provided to carry the shear, that is the shear reinforcement. Okay, so total capacity of the section to resist the shear is divided into two parts: capacity of the concrete to resist the shear and capacity of the shear reinforcement to resist the shear. Okay, or in general, capacity of the reinforcement to resist the shear. So the same I will write down here now. You also write down the same, how the capacity is to be calculated. So capacity of the section to resist shear is calculated as capacity of concrete to resist shear plus capacity of reinforcement to resist shear. Okay, so we have to calculate the total VU is equal to VUC plus VUS. Okay, so what is VUC now? What is the formula of VUC?
Tau C into BD.
Yes. So let us calculate VUC first. Tau C into BD. What is tau C? Tau C is the nominal shear strength. Am I right? So I will go to your code now. So tau c values are given over here. Design shear strength of concrete, tau c. Am I right?
Yes, ma'am.
So it depends upon the percentage steel and grade of the concrete. What is the grade of the concrete given?
M20.
M20. And what is the percentage steel? I think we have not calculated it. So let us calculate first the percentage steel. So I will do the calculation here only, percentage steel, because AST is known to us. So I will quickly write down percentage steel as AST upon BD into 100. So quickly tell me the value.
0.75.
0.75. Okay. All right. Now for this 0.75 value and for M, what's going on today? Okay. So for percentage steel of 0.75, okay, we have a value directly in the table. So there is no need to interpolate the value. 0.75, and for M20 grade. So this is 0.75 and M20 grade, the value of tau c is 0.56 from this table. Okay. So let us write down that value here. Tau c is 0.56. I will simply write down here, or wait, we'll write down properly. So far, percentage steel equal to 0.75 and M20 concrete. Tau c is equal to, what was the value? 0.56, am I right?
Yes, ma'am.
Yes, ma'am.
So VUC is equal to 0.56 into B is 250 into D is 500, right?
70
Yeah, ma'am.
kilonewton.
Okay. 70.
Yes, ma'am.
All right. So this is about VUC. Now we have to calculate VUS also, because the total VU is VUC plus VUS. Okay. VUS itself is an addition of again two values. What are those? Tell me quickly.
VUSB and VUSB.
Correct. So VUS is equal to VUSV plus VUSB. That is the shear force resisted by the shear reinforcement and shear force resisted by the bent up bars. Now again the problem statement, the bent up bar details are not given. So we have to consider VUSB equal to 0 here again. Okay, because there are no bent up bar details are given. So we will assume that there are no bent up bars, and hence VUSB will be equal to 0. Let us calculate now VUSV. Tell me the formula for VUSV.
0.87 FY into ASV into D upon SV.
Correct. So let us find out ASV now. ASV is nothing but area of shear reinforcement. So it will be pi by 4. What is the diameter of the shear or the stirrups?
8 mm.
8 mm. Okay. So, and it is mentioned that it is two-legged. So multiplied by 2. So what is the value?
100.53.
100.53. Okay. This is the area. And the spacing, that is SV value, is also given. What is that value?
200 mm.
200 mm. Okay. So let us put now all these values in this formula to find out VUSV. .87, grade of the steel is 415, right? Into
Yes, ma'am.
100.53 into effective depth is 500 divided by 200. So find out VUSV.
90.7.
9,
90.74.
90.74 kilonewton. Okay, this is your VUSV. Now find out VUS, total VUS, which is the addition of VUSV and VUSV, right? So total VUS is equal to VUSV is 90.74 plus VUSB is 0. So this value is 90.74 kilonewton. So what is the VU? VU is, I will write down again, VUC plus VUS. So what is VU?
160.74.
First of all, tell me VUC value.
70.
70 plus 90.74. So VU is coming as
160.74.
160.74 kilometer. Okay, this is VU. So this is the total shear carrying capacity of the section. So when you design or in other words, this is when we consider the external load acting on this particular beam, the shear force developed due to that external force should not be more than this value, VU value, 160.74. Otherwise, the beam will fail. Okay, because that is the only capacity of the section to carry the shear force. Is it clear? Capacity based problems.
Yes, ma'am.
Okay. So do you require one more problem or this is sufficient? Because this is much more easy. All the data are given, only we have to calculate the VUC, VUS and VUSV. Okay. So shall we proceed to the next design problem?
Yes, ma'am.
Yes, ma'am.
Okay. So I will go to the earlier slides. I will quickly revise now the design steps for design of beams. We have discussed all these in detail on Monday's lecture, during Monday's lecture. So I will quickly go through these steps. When we design a beam, first of all, we have to decide the size of the beam, in which we have to decide the width and depth, and also the effective span calculation. Okay. Now, I could not upload all these PPTs on VOLP, so you must not be having these steps. So if you have written already these steps in your notebook, fine. Otherwise, quickly you take a photograph of the screen, because we will require all these steps now. We are going to design one beam now. So quickly you take a photograph and let me know once you finish taking picture. Over. Students.
Yes, ma'am.
Okay. Now the second step is load calculation. So whatever the load is coming from slab, we have to calculate. So if it is a one-way slab, this is the formula. And if it is two-way slab, this is the formula. Okay. Now today, whatever the problem we are going to solve, in that problem, the load calculation is already given. So don't take picture of these slides. Because I have to maintain the time also, no, for your lecture, that's why. Then what is the load coming from the wall and the self weight, that also is calculated by using this formula, and that the entire load acting on the beam is given, so no need to do these steps for the problem. Then we have to calculate the ultimate bending moment and shear force. Okay, so depending upon the type of the beam, whether it is simply supported or cantilever or fixed beam, we have to calculate these values by making use of appropriate formulas. So just take a picture of this slide again. Once we calculate maximum moment and shear force acting on a beam, we have to calculate MUR max also to compare with the maximum bending moment. Okay, and to decide whether the given beam is singly reinforced beam, or whether we have to design it as singly reinforced beam or doubly reinforced beam. So to decide that, we require this step. Is it over? Have we finished?
Yes, ma'am.
Then we have to calculate the area of main steel, this formula. Last time I have explained you how we arrive at this formula. So it is better to make use of this formula directly. Otherwise, the concept of using the formula of mu, then putting the value of xu in terms of AST, and then calculation of or the solution of the quadratic equation in terms of AST, that concept is also okay if you don't want to mug up this formula. Okay. Here also, when you put the value of all these, you need to solve the entire equation here. Okay, is it over? And we have to verify the AST value with minimum and maximum value specified by IS 456. Have you taken photograph of the same?
Yes, ma'am.
Yes, ma'am.
Okay. Then distance between the bars that we have to calculate. Normally we provide the equal distances. To decide the distance between the bars, suppose 3 number of bars are there and total width of the beam is say 300 mm. We leave certain side cover. Normally it is considered as 30 mm. So 300 minus 30 from left hand side, 30 from right hand side, 300 minus 60. For that much spacing, we divide we place the bar at equidistant. That is the process. But once we once we place the bars, we have to go for this check without fail. So just take picture of this slide also. Check for the width. Okay. Is it over?
Yes, ma'am.
And the next step is designed for shear reinforcement. The steps are already known to you, so I am not going to explain it again. Once we complete all the steps up to 7 number step, the remaining part today again you are going to do as a homework because it is shear reinforcement design. Okay, the same steps you have to follow whatever we have discussed yesterday. Okay, so let us solve one problem. I'm going to dictate now that problem because I forgot to type it in the slides. Just within 2 minutes, all of you have to note down that problem and then we will start its solution. So all of you just note down the problem statement. A simply supported beam. I hope you are writing. A simply supported beam of a clear span 5 meter is subjected to ultimate uniformly distributed load, or UDL, you can write down, is subjected to ultimate UDL of 30 kilonewton per meter. 30 kilonewton per meter, inclusive of its self weight. Inclusive of its self weight. The beam is resting. The beam is resting on the column 230 mm wide. 230 mm wide. Design the beam. If M20 grade concrete, design the beam. If M20 grade concrete and Fe415 grade steel are used. And Fe415 grade steel are used. Is it over? Everybody has written?
Yes, ma'am.
Okay, so I will simply read the entire problem statement again. A simply supported beam of a clear span 5 meter is subjected to ultimate UDL of 30 kilonewton per meter, inclusive of its self weight. The beam is resting on the column 230 mm wide. Design the beam. if M20 grade concrete and Fe415 grade steel are used. Okay, so let us quickly write down now the given data. Okay. So given data, what is given first?
Clear span 5 meter.
Yes, the clear span is denoted by L. The clear span is given as 5 meter. Then the load is given, which we denote as WU because it is the ultimate UDL, right? So what is the value?
30 kilonewton per meter.
30 kilonewton per meter, and this is inclusive of self weight. So this is the total weight acting or total load acting on a beam. And what is the next value given?
Width of column 230 mm.
Okay, so column of width of the column is given. It means it is the width of the support they have given. So I will simply write down width of the support BS as 230 mm. Okay. Then grade of the steel and concrete is also given. They have given M20 grade concrete and Fe415 steel. Okay. Now for this given data, we have to design the beam. Let us start with the first step. What is the first step? What is the first step?
Size of beam.
Yes, we have to decide size of beam. So we have to decide B value, right? Normally the width of the beam, how it is decided?
Width of wall or width of support.
Yes. So width of the wall is not known to us, but width of the support is given, which is 230 mm. So I will consider it as 230 mm. So let us consider the width of the beam as 230 mm. Now the second step, we have to decide the depth of the beam, right? So depth of the beam. There is one criteria given to decide the depth of the beam. What is that?
Clear
Clear
span
span
by
divided.
10 to clear span by 16.
Yes. So the clear span is given as 5 meter. Let us write down it in mm. So for 5000 by 10 to 5000 by 16. Within this range, we have to decide the or adopt the depth of the beam. So tell me this value. This is 502. What is this value?
312.5.
312.5. So within this range, we have to decide the depth of the beam. Normally, we go to the higher value. So let us adopt this value. Okay. So adopt D is equal to 500 mm. Okay. Immediately, we will decide what is the effective cover we are going to provide. And then we can immediately calculate the effective depth of the beam also. So to decide the effective cover, let us go to the clause given in the steps. So to decide the effective cover, we have to refer this table, table number 16. So I will open the code now, and all of you also open the code and the table number 16. Okay, now in the given statement, problem statement, the exposure conditions are not given, right? What is the exposure condition, environmental exposure condition, etc. Based on which actually the table 16 provides the data for effective cover. What was the page number?
47.
Yes, this is the table, right? So for mild, moderate, severe, very severe and extreme exposure conditions, the nominal cover are given. So let us consider that the beam is to be erected in a severe condition or very severe condition, and let us adopt the effective depth or effective cover as 50 mm. I'm considering directly the effective value. Okay, so we will write down here, providing effective cover DC is equal to 50 mm. Okay, so what will be the effective depth of the beam? 500 minus 50, so it is 450 mm. Okay, now the next point, we have calculated width, decided width, decided the overall depth and effective depth of the beam. Now we have to calculate the effective span. Clear span is given, but for all further calculation, that is for calculation of bending moment, shear force, will require span of the beam, and that is always considered as the effective span. So let us calculate now the effective span. Now how the effective span is calculated? There is a criteria. What is that?
Clear
Go back.
span plus effective depth of beam or center to center distance of supports.
Correct. Tell me the page number. I will go to the code clause.
Page 34.
Page 34. Yes. Okay, now the beam, type of the beam given is simply supported beam, right? So for simply supported, the effective span of the member should be taken as clear span plus the effective depth of the slab, or center to center distance between the supports. Okay, whichever is less. So the criteria is least of
Huh?
first point, the center to center distance between support, right? Center to center distance between support. So the width of the support is already given. So it is 5,000 mm effective, or the clear span, plus the center to center support means the width of the support is 230. So from left hand side 230 by 2. I will write down all details. And from right hand side 230 by 2. So that will be the center to center support. So in short, it is 5,000 plus 230. So we will get is 5230 mm. This is the first value. Second value, clear span, L clear, plus the effective depth. Clear span is 5 meter or 5,000 mm, plus effective depth is 450. So this is coming as 5450 mm. So out of these two, the least one is to be selected. So this is my least value. So my effective span is 5230 mm. Okay, is it clear to everybody? Effective span. Guys, are you there?
Yes, ma'am.
Yes. What is the next step?
Calculation of ultimate bending moment and SF.
Correct. So let us calculate ultimate bending moment and shear force. For simply supported beam subjected to UDL, what is the formula for calculation of maximum bending moment? Simply supported beam subjected to UDL, maximum bending moment.
W square by
W
8.
by 8.
WL square by 8. Yes. So here our W is nothing but ultimate value, WU. L is nothing but the effective value. So WL square by 8. I will write down. So W, what is the value of W?
30.
30
kilonewton per
meter. Okay, so I have to consider the value in meters now. Okay, I have considered the load in kilonewton per meter. So length also I will consider in meter. So 5.23 meter square upon 8. So what is mu value I'm getting?
one 102.57.
Okay, this is in kilonewton meter. Now next is shear force Vu. So again, for simply supported beam subjected to UDL, what is the formula for maximum shear force? Guys, you
WL by
forgot
2.
most one.
WL square by 4.
Hey,
WL by 2.
shear force. WL by 2. So WU into L effective upon 2. Okay. So again 30 into L effective is 5.23 divided by 2. So VU is
78.45.
78.45 kilonewton. Okay, so we have calculated the moment and shear force acting on a beam, for which now we have to design. For this moment value, we have to design the tension reinforcement, whereas for this shear force value, we have to design the shear reinforcement. Okay, so let us consider first the design for flexure. That is, we will calculate the area of the steel for the main reinforcement, that is for tension site reinforcement. Before that, we have to decide whether the given beam is to be designed like a singly reinforced beam or doubly reinforced beam. For that, we have to compare this mu value with the maximum ultimate moment, or MUR max. So let us calculate the MUR max first. That is the maximum moment of resistance. What is the formula?
0.36 B into FCK into XU max in brackets D minus 0.42 XU max. Ma'am, D minus.
Okay, yes. So let me correct that. This is D minus, right? So tell me first XU max value. I will write down here only. XU max. How to find out XU max?
0.48 into D.
So
216.
sorry, 0.48 into D, right?
Yes.
It is based
Ma'am,
on, I'm just
Grade.
revising all this. Grade of?
grade of steel.
Correct.
Steel.
Yes. So what is this value we are getting?
216.
216 mm, right? So put all these values here. See, if you are well known about the RU max values, which we have calculated as a design constant, if you are knowing the RU max values corresponding to the grade of steel and grade of concrete, you can directly put that formula, use that formula also, that is RU max into BD square. That gives us the maximum, maximum moment of resistance or ultimate moment of resistance. But for different values of grade, different grades of concrete and steel, you need to mug up the RU max values. So I always go to the basic formulas which we use for getting those design constants. So put all the values and tell me the value directly. MUR max.
128.51 kilonewton meter.
0.51 kilonewton meter. Compare this value with the mu value which we have calculated. It is greater than mu. Okay. So design the beam as, tell me, design the beam as singly or doubly?
Doubly reinforced.
Singly or doubly?
Doubly.
How? See, the total moment acting on the beam is less than MUR max.
Singly reinforced beam.
Yes, so it should be designed as a singly reinforced beam. I'm writing short form, singly reinforced beam. Okay, design the beam as singly reinforced beam. It means we have to calculate only AST. There is no need to calculate ASC. This is the difference in singly and doubly. Okay, so let us calculate now the AST, that is calculation of main steel. This is the step number 3. Okay. So calculation of main steel. AST. I will write down that formula, which is 0.5 FCK upon Fy into bracket 1 minus under root 1 minus 4.6 mu upon FCK BD square bracket complete into BD. Into BD. Okay, this is the formula for AST. Let us put all the values. 0.5 into 20 divided by 415 into bracket 1 minus under root 1 minus 4.6 into mu value we have calculated in kilonewton meter, right? Where is the mu value? 102.57. It is the value in kilonewton meter. We are putting all these in Newton mm. So let us put this value also in Newton mm. 102.57 into 10 raised to 6. Okay, divided by again 20 into B, we have decided 230 into effective depth 450 square. Okay, bracket complete into B into D. So B value is again 230 into D is 450. Put all the values which we already written. Calculate AST. Tell me the value of AST. Guys, are you doing the calculation?
Yes, ma'am.
Come on, fast. We have 5 minutes left only.
742.11.
Again, please.
742.
742.11.
Okay, 742. Let us consider. Okay, 742 mm square. Now there is a check for this AST. It should be greater than the minimum value and it should be less than the maximum value. So AST minimum value, what is the formula? AST minimum, tell me the formula.
0.85 BD upon FY.
0.85 BD upon FY. Okay. So let us put the values. 0.85 into B is 230, into D is 450, divided by FY is 415. Okay. So tell me the value. अर्चना मी लेक्चर मध्ये आहे, मी कॉल करते तुला. हां.
211.98
211.98
mm square.
yes, and it should be less than or equal to AST max. So let us find out what is the AST max. Tell me the formula.
0.04 B into capital D.
Correct. So put the values. It is 0.04 into 230 into 500 na total depth.
Yes, ma'am.
Okay. So tell me the value.
$4,600.
4,600.
Okay. Correct. Now we have to decide what diameter of the reinforcement we are going to provide and how many number of bars we have to provide. Okay. So the simple calculation that the total area of the all reinforcing bar is known to us. That is the required one is 742. And now we have to decide what will be the area of the single bar. So if I wanted to calculate AST in terms of the area of the single bar, it will be simply AST of a single bar multiplied by number of bars is equal to total AST, right? So if I divide the total AST by the area of a single bar, I can find out number of bars. This is a simple logic. Okay, so if I will assume that I am going to select 20 mm bar diameters. Okay, so let us consider 20 mm dia bars. Okay, so area of the single bar, what will be that? Pi by 4 into d square. What is this value? Guys?
314.15.
Okay. So my number of bars I can find out as number of bars is equal to total AST divided by AST of single bar. Okay. So total AST is 742 divided by 314.15. So number of bars.
2.36.
2.36.
So 2.36, such odd number we do not provide. So we have to provide 3 bars. Okay. So if we provide 3 bars of 20 mm diameter, what is the provided area of the steel that we have to calculate? So AST provided is equal to pi by 4 into d square into 3. Just calculate this value.
942.45.
942.45
45.
mm square. This is the provided area of the steel. Again, we will check whether it fits between the given limit. It should be greater than 211.98 and it should be lesser than 4600. So the provided area of the steel is correct. So this is a provided area. Now we have to decide in the next step, we have to place these reinforcing bars in the beam such that whatever the width we have selected, it should fit in that width along with whatever is the spacing we are considering between the bars. Okay. So in short, the next step we have to consider for the check for width. I will go directly here because we have already decided the cover. Bottom cover we have provided effective cover of 50. So clear cover will be 50 minus half the bar diameter. So it will be 40. Clear cover will be 40. Side cover we normally provide as 30 mm. So let us consider check for width now. Okay. What is the formula? I will quickly draw the diagram here. I am sitting today with a scale. Yes. Okay. Okay. So we have 3 bars, okay, of 20 mm diameter. There will be some side cover. Okay. This is the half of the beam. So providing, you just write down 30 mm side cover. Okay. It means this distance we have decided as 30 mm. Okay. Or it is denoted as per our formula. If I will go back to the design steps over here, our formula is C1 is the side cover. So just quickly tell me this formula.
2C1 plus N phi
Hmm.
plus N minus 1 C2.
Correct. So if I will consider 30 from this side, 30 from this side, so it will be total 230 minus 60. What is the width? 230 minus 60. It is 170. Okay. So C1 is the distance from the center of the bar. Okay, 30. And from center of this side to side, it is also 30. So 230 minus 60, it is 170. So this total distance is coming as 170. Okay. So 170 by 2, I will get the C2 value. Okay. C2.
Ma'am, in the diagram, C1 is shown from the end.
C1, okay, let me check the diagram. Wait. C1 is shown from the end. Correct. Now diameter we have considered completely. Right. It is correct. So this should be from the clear side. This is a clear cover. Fine. All right. So 2, I will put the values here. 30 plus n number of bars 3. Diameter is 20 plus n minus 1 C2. C2 we don't know actually. C2 I will write down C2 over here as an unknown term and I will equate this to the width. This is the best idea to find out the required width. Okay. So this is the width, total width required, right? So what is the total width? 230. Have you got what I have done? And I am now calculating C2. What is the C2 value you are getting?
55.
Okay, so this is 55. Now we have to check as per the clause what is C2 value. Okay, so if I will go back here, distance between bars. So these are the criterias. I'll make it full screen. These are the criterias. Okay, C2 should not be less than greatest of the following: the diameter of the bar if the diameters are equal. So we have calculated C2 as 55. It is greater than, or I will write down first all these three criteria: diameter of the bar, then diameter of the larger bar. It is, we are providing all the three bars of same diameter, so it is 20 again, and 5 mm more than the nominal maximum size. So normally the nominal maximum size is considered as 20 mm. So 20 mm plus 5 is 25. So I will simply write down these three criteria over here. C2 should not be greater than, greater of.
Should not
First,
be less than.
should not be less than or greater than.
Less than.
Less than, ma'am.
Usually, wait, the horizontal distance between two parallel main bars shall usually not be less than. Okay, should not be less than. Correct? First one is diameter 20. Second one is again 20 we are getting. And third one is maximum size of aggregate plus 5 mm, which is normally considered as 20, maximum size of aggregate plus 5, so 25. So C2 should not be less than greatest of these three value, that is, it should not be, C2 should not be less than 25 mm, and it is satisfying our criteria. Okay, so whatever the diameter of the bar we have considered and whatever the width we have provided, everything is okay, right? Have you got it, students?
Yes, ma'am.
Okay, so the next step is design for shear. This part you are going to do as homework. Okay, design for shear reinforcement. And this entire problem, when you solve in the examination, it carries 12 marks. Okay, the entire problem, the weightage is of 12 mark. Entire design of beam. Is it clear, guys? Design of the beam. We have seen one case, that is design of singly reinforced beam. In the next lecture, we will consider the second type of the beam. So today, quickly give me the attendance, because already we have crossed 5 minutes. Give me the attendance on this link.